Et bonjour les amis. Wait. Now, I got a news. This video is gonna be in English. Why? Because I wanna. I'm still gonna continue the other series in Portuguese, but this is like the same deal, making a Minecraft from scratch on Unity. But it's gonna be in English because a lot of people like came to my videos and like almost like 50%, I'd say, maybe not that much, like 25% of the comments were like in English, or were like saying thank you or something. And I just thought like I was maybe I will start getting more views by doing this, since like English is like an international language thing. But anyway, let's get started. So we are gonna start by doing by importing actually the character controller. I'm not gonna import the third person controller because we don't need that. We just need those three scripts, and I think that's it. So let's import that. I made two little folders. They are empty. I made the scene sure, like looking around right now, it's an empty scene. Just yeah, and I have this shader, which is basically an unlit vertex color. So basically, it doesn't receive any light when an object is applied to it, and it shows the texture and the vertex color. You can find this pretty much anywhere on Google and on the Unity forums or something. It's not such a hard find. I found it by googling. I didn't make it. I didn't buy it or something. It's just go look for it. Jesus, it's not called World. I just call it. It's called Unlit Vertex Color Light Map. That's how the creator called it. Anyhow, for the textures, we're actually gonna. I don't know. I was like looking at the videos. I'm actually gonna go on Google. I'm gonna type Minecraft. Not Minecraft.net. Actually, this is the new version isn't out. Minecraft that. No, not that net. Minecraft, I don't know, texture. We need a texture like this. So you basically look for a texture you want. Let's see, I don't know, a cool texture pack or something. What is this? I can actually use a bigger sized image. It won't really affect much the frames per second. This isn't French. I'm still learning French, you pieces of shit. Give me a second. Okay, this is more like it. Okay, so I think this is the texture I was using. No, never mind. This doesn't seem much different. I found here a texture. I'm not in love with it. I really hate it, but I've been looking for a texture and I haven't found it, and I give up. So Minecraft. I'm gonna save it over here. I'll just call it terrain.png or some shit like that. Why isn't that transparent? Anyhow, let's just go ahead and shake the texture out. It kind of seems like more. Yeah, it's just my impression. That's stone, that's grass. Okay, everything is good to go. Whew. We're off to a great start. I've got to make a folder, which is the prefabs folder. And then I'm gonna make a script. I'm gonna call it chunk. And yes, I do know chunk is written like that, but I've been writing this chunk like that for like thousands of years ago, so I don't give a shit how it's written. Yeah. So here we have our chunk. On this chunk script, it's gonna be like basically we're gonna make something different than the last one. I did like an infinite world, which is gonna do as well as of course, but I did it infinitely in like vertical wise and horizontal wise. On this video, I'm just gonna make it infinite horizontal wise, and there's gonna be a limit to the sky. For the only reason that that's the easiest way to approach light maps. If you want to have like a light map, and instead of using like shadows and making things look neat, you gotta have a finite height. So for instance, I'm gonna make a public static int chunk stack. Let's say 10 chunks. I don't know, we can change that. So basically what this is going to do, we're going to stack like 10 chunks on top of each other. So we make, that's going to be basically our world height. It's not going to be 10 blocks, it's going to be 10 times 16, which is basically going to be our chunk width and height. So public, again, static, not static, what I mean public const, that's what I meant, not static. Public constant, int width, which is equal to 16, and height, which is equal to 16 as well. This is like what Minecraft uses. I don't know, it's just, if you want to change that, want to make it bigger, smaller, but if you make it bigger, it's going to take a lot longer to load. If you make it smaller, it's going to load faster, but it's going to have more bits to load, if you know what I mean. Yeah, that's, you can play around with the values when we got some system actually working. Then I make a public static dictionary. I'm gonna have to import system not collections, that generic dictionary. The key is gonna be a vector free, and the value is gonna be well, it's gonna be a chunk. And I call this chunks, which is equal to dictionary. Just gonna types out for us. I'm gonna make a quick function here. Public static chunk get chunk at vector free position. Then to find like the chunk's position, we gotta do some crazy shit. Alright, be right back. Anyways, I'm back. Sorry for that. So what we were doing, we gotta find out the position of the chunk. So basically, if we say position, it's most likely it's not gonna be like the exact position of the chunk. So we gotta find like the exact position of the chunk. So how are we gonna do it? It's quite simple. So we're gonna do int x, which is equal to math dot get float. Nope, not float to int. Not get float. Here I'm gonna do position dot x divided by our width, and then I'm gonna do times width. So no, this isn't gonna give like the same value, because as we are defining, like we're dividing this, okay, then we're multiplying. I do understand, like, if you're confused, but we're transforming our value to an integer, so it's not gonna be the same value as it outputs here. It's gonna be changed. This works like an ID thing. It's, if you like put it in Paint and start doing and testing this out, you're gonna understand it quite quickly. It's not that hard to understand. So that's gonna give us the exact chunk position. So I'm gonna do vector free c position is equal to new vector free x, y, and z, and then we're just gonna return. Actually, we need to first check if the dictionary contains that chunk. So chunks that contains the key c position. I forgot the if contains that key. Not oof, if Jesus. I'm just gonna say return chunks C position. Otherwise, we're gonna just return null. We're gonna as well do a little thing as set chunk. Again, we're gonna get the position. We're gonna transform the position to those coordinates, which is gonna be the same, but we just want to make sure that we input the same thing. Now that if it contains, we need to put bool. If it contains, then I'm gonna say false. We didn't add it because it already existed. But if it does not contain, I'm gonna say true. We added it, and we need to actually add it. So chunks that add position chunk value is gonna be well, that needs to chunk this. Can I call it this, or is it gonna? Yeah, it's gonna convert this chunk. Okay, there you go. So we got two functions to manipulate what we do in there. I'm gonna also do public static boolean remove chunk. Vector free position. I'm gonna do the exact same thing. Not the exact same thing. We're gonna check if chunk contains that key. Then we're gonna do chunks that remove. Well, set position. Return true. Otherwise, return false. We're gonna remove it because it didn't exist. And actually we should like do destroy game object. Oops. Yeah, we cannot access it like that. We're gonna do chunks position dot game object and put this up here, and then we destroy the list. So that's okay. Set chunk. Should we really say set chunk? I'm gonna call it add chunk. It seems more appropriate. I'm gonna create a chunk. Game object chunk, which is equal to game object dot instantiate. That was game object. I need to give it a name if I'm not mistaken. I'm gonna say chunk plus C position. Isn't new? No, yeah. We need to do like it's equal to new game object. We don't need that. Then we're just gonna say chunk C, which is equal to chunk the add component. We're gonna add this component. We also need to add though chunks that add mesh collider. I'm not gonna use the mesh collider with this one. We're gonna do our own collision system. I'm gonna add the mesh renderer and the mesh filter. That's all we're gonna need. Actually, we might as well do mesh renderer. I didn't type it correctly. So mesh renderer, that material, it's equal, and then we need the material. Public material mat. Now that's not gonna work correctly. We need like, I don't know, I'm gonna make a new world script. And this world script is gonna contain public material mat. And then well, static material mat static. Then on public awake, I'm gonna say mats is equal to mat. It's not auto-correcting me because I need to restart this thing. I forgot the void on the. I said public awake. It should be void awake. Holy moly! Yeah. Anyways, void awake, and that should take care of our issues. And here we're gonna say world that mat static. So we're gonna need to make a empty game object. I'm gonna remove the camera. Empty game object, I call this world. I'm gonna add the world script to it. Then the material, I'm gonna create a new material. I'm gonna go to prefabs, I'm gonna create a new material. I'm gonna say this chunk. I'm gonna go ahead and put that material over there. I want to assign the unlit vertex light map or the material, the shade that you have, and then the texture. Well, I'm gonna use the texture. I don't know if I have to like say that it's supposed to be transparent. Actually, yeah, this thing's not going to support transparency, the shade that I'm using. Yeah, that's going to be an issue. If you have like a shade, I think I can find it actually, but if you have a shader that's unlit, that has the vertex color, and is like transparent, like you can see through the grass or something, just tell me, because I really need it. Okay, so we got our chunk material. We have the world, and here on the world, I'm gonna say void update. Do I have like a chunk exists? No, I have get chunk. That works as well, I think. I'm just gonna do like chunk exists, so I can like check real quickly if there's a chunk there. Public bool chunk exists. Vector not position. If contains, then I'm gonna say return true, otherwise return false. just so can make things more fast and more organized. I'm gonna do int x equals to 0. Well, it's not gonna be equal to 0, but I'm just gonna put a little thing here. Oh, for fuck's sake! Thank you. I'm gonna make a public constant int view range. It doesn't really have to be constant, but I just feel like we shouldn't be really messing up with this for now. This is how many chunks you see in all directions. Like in front of you is gonna render like 10 chunks, each of them with all their height and stuff. So it's equal to, well, view range divided by 2, and just minus view range divided by 2, and here is, well, it is smaller than range divided by 2, x plus plus. So I'm going to do this for all the coordinates, well, actually for only x and z coordinates, just like so. And we're going to say vector-free chunk position. This has to be like an approximate position. It doesn't really need to be a precise position. So vector-free chunk position is equal to new vector-free x times chunk that width, and here's going to be well, 0, and here's going to be z times chunk that width. So you just want to do like a little plain thing. Like there's not going to be chunks into y for now. We're gonna add that later. Then we just say if chunk exists at that position, then we just continue. Otherwise, if the chunk is not existent, we add a new chunk at, well, C position. Isn't that amazing? So if we run now this code, it should work. I'm gonna actually do here view range half, which is view range divided by 2. And here we just do minus view range half, and here we do view range half. So 0 is like our middle point. If I play, as you can see, it spawned all those chunks around the 0 coordinate. Cannot really. Why isn't it? Oh, of course, we're not setting this position. Chunk dot transform that position is equal to C position. And let's as well check, as you can see now, it has the same position as it says there. It has our chunk material, has our chunk script, and it has the whole thing we need to render our meshes. So that's a nice start. That's a very nice start, I gotta say. Now we need to add some more variables here. Let's keep all like constants together. Public I keep saying public byte, why not? Let's do a byte. Map. 3-dimensional byte called map. I think we can initialize it right here. If we cannot, then apologize me. Yes, we can. So public map, which is equal to new that. So this is going to be a huge amount of data. Well, that's not huge really. I'm going to make a height map. This is going to be byte as well, and it's going to be actually a 2D array. Oh snap! That's not what I meant to do. Here we actually need to kind of approach this differently. We need to make an array of arrays, if that makes any sense. We're gonna actually use a list. So this list is gonna be more organized. I'm gonna say list, a list of byte for the array bytes maps. It's equal to well, that. And then we're gonna initialize it as we add the maps. Since we're gonna have just one script for the chunk and you have a bunch of other meshes like stacking on top. We're not gonna like spawn a bunch of chunks on the top of another. We're just gonna spawn one chunk in the middle, and that chunk is gonna control all the ones that are on top or below. It's like the master chunk of that like column, whatever. If that makes any sense. Then we're just gonna do a public, not public, void update. I'm gonna make some public variables. Public bool dirty, public bool light dirty. So basically, if we say this boolean is equal to true, it's gonna recalculate the map and mesh. Well, the map is gonna recalculate only once. Calculate only once. Sorry. So if it is dirty, if it's the same first time, we're gonna calculate the map and the mesh. Otherwise, it's just gonna calculate the mesh. So if you break a block, we just say that this chunk is dirty and it needs to recalculate. And if you say light dirty is equal to true, we're just gonna recalculate the light. So if you don't change any block, there's no point in recalculating the whole mesh. We're just gonna recalculate the mesh colors, which is gonna be the light. So if dirty, I'm gonna make a bool calculated map, which is equal to false. If did not calculate map, then we calculate map otherwise. Well, we don't really need to say otherwise. Just we're gonna make a public void C map, which is gonna be calculating the map. And then I'm gonna make another void, which is gonna be C mesh, which is gonna calculate the mesh. And another void, which is gonna be C light, which is gonna be calculating the light. And that one is gonna be if light dirty. I'm gonna make another static variable, which is gonna be boolean, which is gonna be working, which is equal to false. So I'm gonna say if working, I'm gonna return, we're not gonna do anything. If it is there, then I'm gonna say working is equal to true. If it is light, I'm gonna say working is equal to true. We then need to say when you have finished with all these, working is equal to false. Oops. Like so. And also, we're gonna say dirty is equal to false, and like dirty is equal to false. This right now is going to calculate all in the same frame, so we later on want to make like some iCoroutines or something to make things more performance friendly. But yeah, so this is where we're gonna stop for now. It did some pretty good job. We spawned some chunks around. We still need to make the maps and the mesh actually pop up. The light, we're gonna take care of that later on, because it's not that easy to implement our own lighting system. But it's not gonna be that hard as well. So I hope you enjoy this this video. Keep tuned for the episode number 2. And fuck you.